and we get the answer we expected. Whew. And here's another test, pretty similar to that one, but the input data is slightly different. We're testing a different edge case, get a different answer, but we do get a different answer. Whew. Excellent, okay? But each of these, right, has a complexity of 1. What does that mean? It means they are specific. Each test is absolutely specific. You don't test the answer might be this, or it might be that, or it might be something else. No, you test that it's this. And there's another test for that, okay? They're specific. Why do I mention this in so much detail? Because you often hear the idea that your tests are a specification, right? And what is the first 8 letters of specification? The word specification. Specific, right? Now, if the tests are aiming to be specific, what is the code that it's testing aiming to be? The answer is general. This is the way that the cookie crumbles when you're actually doing this idea, when you're following this idea through, yeah? We have lots of potential duplication here. And when you have duplication in the test, it's not always the right thing to do to refactor it so you avoid the duplication. There is a cost to do that, okay? But in this code over here, that doesn't apply. Because you're not aiming to make each of these individual tests simple, linear, with a straight linear flow, okay? You can read them from top to bottom. Bang! You can read it and understand it, okay? There's less hopping about to other functions to set stuff up, okay? Yeah? So you should be much more aggressive about refactoring duplication over here, yeah? Shouldn't really give it a thought, yeah? But over here, it's not the same. Duplication over here is not the same, okay? Just to give you a quick example, supposing you had 2 tests, test A and test B, and they had the same initial setup. Say the first 4 statements happened to be the same for both cases, right? Yeah? Pretty standard. What would you do? Any standard unit test framework has a way to solve this problem. Extra method. Setup method is the one I was looking for, okay? You can pull these duplicated 4 lines that's the same here and here, and you put them in a method in C#, you just write it as setup, annotate it with annotations, setup, okay? It can be called whatever you like. Blah, blah, blah. And there's those 4 lines there. Yeah? And they're gone from here, and they're gone from here. Because there's magic, right? Yeah? The magic is the test framework you're running. It sees through reflection that this method is marked as a setup method. There's a magical annotation, setup. And it says, aha, I know what that means, right? It means create an instance of this, and then run the setup, and then run that test, and then run the teardown. Throw that all away, create a new instance of the object of the class, run the setup, run this test, the other test, run the teardown, throw it away. On and we go, okay? Excellent. But I feel that that's a step too far. Because it's vanished from here. You've lost that element of the linear flow. You can't read this as a single flow. This is what I do. This is what I assert. It's all one place. You have to jump around. Maybe this is 3 screens further up or something, okay? Now, I'm not saying you should put those 4 lines back in here. But what I am saying is there's a middle ground which I feel is better than either of the alternatives. And that's you get rid of the setup, you choose an appropriate name for this, and you put that appropriate name there instead of the 4 lines. And you retain that linearity. Okay? Maybe you do that already, maybe not. If you haven't, I urge you to try it, see how it feels. Yeah? Because as I get older, I realize most of the time I kid myself that I can think about whether something is working here, but actually, a lot of the time, this is more accurate. Right? How does it feel when you're doing it? It's often more accurate. Okay? So that's just a little example of what we mean by this idea of each test is linear. It's specific. Okay? you have a question still after that? No. He did. Right. I love it. Yeah. The metaphor making an analogy with a joke, and all you get is the punchline at the end without the lead up, the question leading to the punchline. I didn't know that. Thank you. Okay. Starting with the red. That was the one I promised I'd come back to, wasn't it? Who's heard of that guideline? Always make sure your test always fails first. Who's heard of that one? Few? Okay. I imagined it might be more. Okay. Let's think about the reasons why it's a good idea to make sure your test, when you run it, fails. I can think of at least 2 different reasons why that's a good guideline. That's one. Test that basically, it's running. Yeah? And you shouldn't underestimate that one. I have one particular example from my history. I remember many years ago when I worked for someone else. One particular afternoon coding away happened to be C++. And I thought, blimey, I'm on a roll this afternoon. I'm writing my code and my tests, code and tests, and they're all passing first time. I didn't start with a red. I would just write the code and then I'd write the test and I'd look at it and think about it carefully. And when I thought, yeah, that's going to pass, I'd run it. And sometimes it would pass. Most times it wouldn't. But this particular afternoon, every single test was passing first time. After a few hours of this, I started to get suspicious. Right? It was in my gut. Yeah? Anyone guess what was happening? What was actually happening? Nope. Nope. I was doing my setup. I was doing asserts. A test without any asserts is somewhat dodgy, isn't it? Yeah? All close. No. I wasn't running the tests. I was writing the tests, but I wasn't running them. Clue was maybe it was C++. C++ doesn't have reflection like modern languages like Java and C# has, all right? In those languages, as we've sort of just seen in Ruby, you write the test, and you don't have to add an extra piece of code to call that test, do you? The JUnit framework, for example, sees that it's a test and it calls it for you. And that's exactly the way it should be, because mentally, psychologically wise, why are you there? You're there to write a test. Having to actually remember to call the test as well is frankly just baggage that you shouldn't have to worry about. But this was many years ago in C++, which doesn't have a reflection library, okay? And at that particular time, I didn't know ways of cheating and making it auto-call. I was writing the code and the tests and then manually adding the name of the function to a list of function pointers so that I'd call the test. And I just wasn't adding it in. So I added them back in, and what happened then? Yeah. Added all those test functions that I wasn't calling. I called them. What happened then? They all failed, of course, right? They all failed, yeah? So the first reason, the most obvious reason of making sure your tests run red first is to make sure they're actually running. Right? Yeah? Now that fits very well with the middle D of TDD. What does the middle D of TDD stand for? Driven. Right? Driven. If you're doing the genuinely test first, you write the test first, and of course it's not going to pass. We haven't got the code for it yet. We're just writing the test first. And that's driving our design. It's helping us think about the use of the thing and not getting lost in the implementation, right? Okay? How many times have you looked at a piece of code and thought that you didn't write, and you look at it and you think, well, oh, blimey, this is obviously a solution to something, but it's not entirely clear what it is a solution to, right? Yeah? That's the kind of code you get if you just focus on the implementation without thinking about the use of that code, right? So if you're following that test first mantra, it's natural that you write the test first, and sure, it's not going to pass because we haven't even written it yet, okay? But as we just saw when we did this step, right? There was a moment where I added this third and fourth as it happened. I think it was this one actually, yeah. I added that one, and I was expecting that to pass first time, wasn't I? Right? So that's a slightly different situation, right? I'm not expecting it to fail, I'm expecting it to be green. But I promise you it's really, really easy to write code and tests and think that something's happening that isn't happening. If I was really genuinely sort of being picky about it, I'd have made sure that one failed first, right? For example, supposing I accidentally introduced an X there. Yeah? Does that now run as a test automatically? You have to know the test framework that you're using, okay? Is it that it's doing reflection and it has to start with the word test? And if it does start with the word test, is it case sensitive? What happens if I use an uppercase T? I don't know is the answer, okay? But this is the situation I was particularly addressing. Yeah? When you've got a situation like this, where you're expecting it to be green, right? You've written the test, you've got the code, it's expected to be green. How do you do red first in that situation? Still just as valuable, right? Excellent. And the two possible answers that I gave in my blurb were, number one, you change what you're expecting to receive, change the expected value, or obviously the opposite is you change what you're actually returning in the code, just to force a red. Or you throw an exception in the code, right? How do you feel about those options? I'm not comfortable either, right? And if we choose one of them, why are we choosing that one over the other one? They both feel equally horrible down here, right? Yeah? This is the answer. Why am I changing this to, something like that? Just to force it to fail. And then when I've seen it fail, I change it back to a D to see it pass. That seems weird. But if it's weird, it's just as weird to change the actual implementation. I agree. If I had to choose between those two options, I'd choose changing this one and not the code. Because if I change the code, I could break multiple tests, potentially, okay? Whereas if I change this one, I'm only going to break one thing. But it still feels wrong. Okay. I realized about a year ago there's a third alternative, right? And when I realized this, it reminded me of a scene from one of my favorite films. Who's watched The Princess Bride? Has anyone watched The Princess Bride? Good man. If you're ever after a job, I'll hire you. Okay? Right? It's a fantastic, fantastic film. I really urge you to look it up. It works both as an adult level and at children's level. It's one of those wonderful films that works at both levels, so you can watch it with grandkids or something like that, okay? Princess Bride by Rob Reiner. The director's Rob Reiner, okay? There's a moment in that film when the hero is confronting the baddie. The hero's called the Man in Black. He always wears black. And the baddie's a man called Vicini. And they have a battle of wits to the death. And the battle of wits involves 2 cups of wine. Yeah? The cups are absolutely identical, and the Man in Black, secretly behind his back, pours iocane powder into one of the cups. Now, iocane powder is odorless, tasteless, and deadly. Okay? And the battle of the wits to the death is when Vicini has to choose one of the cups. They both take a cup, and they both drink at the same time, and then one of them is going to be right and alive, the other one's going to be wrong and dead. Yeah? Now, in that situation, it seems, and it's set up, it seems to all the world like there's only 2 possibilities, right? What are the 2 possibilities? Obviously, that they choose that way, and Vicini gets the cup with the iocane, and he dies. Or they choose that way, and the Man in Black gets the cup with the iocane, and he dies. Right? But there's a third option. There's a secret third option, which is, do you remember? He didn't die. Because for the previous 5 or 10 years, I forget exactly how long it is, the Man in Black has secretly been eating a very, very small amount of iocane powder every day to build up a resistance to iocane powder. Right? So he knows it doesn't matter which one the Man in Black picks, because Vicini's going to get the other one, and there's actually iocane in both glasses, right? Right? So the point is, when someone gives you two options, right, don't fall into the trap of thinking those are the only two options. It's never the case that those are the only two options, right? Apart from anything else, you could choose both of them, or you could choose none of them. Or you could say, well, there must be a third option, right? Very easy to mentally fall into that trap of thinking, do we change the code or do we change the tests? Which one do we break, right? And the realization I had was, you don't break either of them. You just make it fail, right? You add a line that says, when this runs, don't bother with your cert, just fail. But you don't have that horrible feeling in your gut because you changed this arbitrarily to something totally arbitrary to make it different than what it should be. Yeah? Then you run it, you get the failure, you remove, to prove that it's actually running, okay? And then you remove that line. Lovely. And I'll tell you, this feels so much better. Right? Yeah? That horrible moment when you're changing something here just to get an artificial red. You don't get that anymore. Okay? So I recommend that, and I'd also recommend The Man in Black and Vicini in the film The Princess Bride. In case my accent is slightly throwing you, or I'm talking too fast, I'll just write it up here. The Princess Bride. This is far more important than coding. Awesome film. So I do recommend starting with a failing test, but that's my current understanding of what that means. Getting rid of that feeling in your gut. Done that, done that, done that. Haven't done that. Okay. The other thing I promised I'd talk about was the word unit. Who does unit testing? Keep your hands up. What do you mean by the word unit? Keep your hands up. Okay, let's see who's going to be brave and give us an answer. What do you mean by the word unit when you say you're doing unit tests? Methods? Some function. Some functional unit was what I heard. Slightly recursive definition there. Anyway. Something that's small. Say again. Out of the usual environment. Okay. Any others? Okay. Functional, behavioral. Can be plug-in. Ola? I like that one. Really, you actually said two reallys, so I'm going to give you both of them. Excellent. Something isolated. I was hoping we'd get there. Yeah, rightly or wrongly, there is now an accepted definition of what the word unit means. Right? Cool, sure. Excellent. Yes. Excellent. Okay. So the accepted definition that is generally now accepted is accepted because it's proved to be useful. It's a constructive definition. It's a useful definition. It's not my definition. It's by a man called Michael Feathers, who wrote a book many years ago. It's called Working Effectively with Legacy Code. Thank you. Yeah? And what he defines legacy code as code with no tests. Yeah? So some people are building legacy code every day, right out of the bat, right? Yeah? And it's to do with isolation. That's fundamentally what it's about. It's nothing to do with size per se. So if you say it's a unit test because it's small, because it's a small class, or it's a unit test because it's small because it's a small function, Again, your gut should be feeling something not quite right about that, because I don't know about you, but I've seen functions that were just massive, right? I've seen not just functions, I've seen copyrights at the top of files that you had to scroll past. You were scrolling and scrolling and scrolling, okay? Let alone functions, yeah? Come back to that in a minute, because that idea of functions is worth exploring, okay? So let's look at this. If I've got a class at C, and I'm writing some supposed unit tests that test C, right? In all but the most trivial cases, you're not testing just C, you're not running just C, because C interacts with other bits of code, obviously, right? Yeah? Obviously, it interacts with other bits of code, yeah? So when you run the tests for C, the runtime also starts to cover other bits of functionality in other bits of code. So does that mean it's no longer a unit test? The answer is it depends. You have to look at these other bits of code that you're reaching into and find out whether they cross what Michael Feathers calls an external boundary. I've also heard it called a boundary of trust, which I like better. For example, a database. Yeah, or a file on the hard disk. Or other things like random number generators. Okay? But basically, to put it in simple terms, code that you didn't write. Yeah? Because unless you're Oracle, yeah, and you actually wrote the code for the database, if you discover some fault which isn't a fault in your code, it's a fault in the database's code, what are you going to do? Right? Nothing you can do. Why were you testing that? Well, you didn't really want to test that at all, really. You wanted to test this thing up here. But that has all these intricate connections to other things, and ultimately that leads to a connection to the database. Okay? So there's some external boundary for your definition of external, based on what your means, right? But you've decided that that code from Oracle, and this code from your operating system, to access the file system, you know, and all the other bits and bobs that, when you think about it, are there, right? They're all on the other side of that external boundary. Now, why is that such a useful definition? Or to put it another way, what's so bad about tests like this that cross these external boundaries so often? Number one, they're unpredictable. And number two, they're slow. That's it. Okay, number one, deterministic. Number two, to use Ola's phrase, really, really fast, right? Now, and those two are obvious, but they are so obvious it's sometimes easy to miss them. If you don't have these two, really bad things start to happen very quickly. Yeah? If you've got tests that sometimes are red and sometimes are green, and sometimes are red and sometimes are green, and then there's a few greens and then there's a few reds, and you look at it and you think, oh, I can't quite actually figure out why the flickering tests, sometimes you hear them called, okay? What happens to those kind of tests? They're ignored. Yeah, either by commenting them out. Again, a number of times I've visited companies and they've got lots of tests by lines of code. You actually look at them and there's whole swathes of them commented out. Yeah, and you say, why are those tests commented out? Oh, you know the answer, but you're asking anyway, okay? Yeah? And they say, well, because sometimes they seem to fail randomly. Yeah? So we commented them out. This doesn't smell too good, right? And the other thing is, they get slower and slower and slower. And there's a really, really important sort of meta rule here, which is called the compositional fallacy. Compositional mistake, right? Human beings are very apt to fall into this. It's when you do something, anything, one time, and the effect of doing that one thing is negligible. Right? So it's fine, it's negligible, right? I'll give you an example. You're a baker, and you're baking a nice cake, and it's got some raisins on the top, right? And it costs you so much to bake this cake, and you sell millions of them, and you make lots of money, profit, okay? And one of the managers comes up to you as the CEO and he says, I found a way to save £1 million. Right? The average number of raisins on each bun that we cook is 100. There's 100 raisins per bun. Well, what about if we take one raisin away? Right? And the manager's really, the CEO is very smart. He says, well, hang on, that's fine as long as it doesn't affect the taste. Because if our customers taste this bun and it seems like actually there's a change in taste, we can't do this. At least we have to think about it more carefully, right? But the manager's ahead of him, okay? He says, no, we've done proper blind taste trials, right? There's no way, okay? We've actually done the 100 raisins and the 99 raisins, blind proper test trial, they can't tell the difference. So the manager says, excellent. The CEO says, excellent, okay. We take away one raisin, which doesn't sound a lot, but when when you're selling millions and millions and millions of these buns, you have to buy less sacks of raisins, you make a little bit of money. If it's enough buns, you make a lot of money, okay? What's the problem, though? I wouldn't have figured this out. It's really subtle. There's a deep systemic underlying problem with this approach, this mental approach. Right? Sort of. The danger is if you give a blind taste trial, 100 raisins, 99 raisins, and it was fine, so you take a raisin away, what happens a year down the line? A different manager comes up with another idea and they say, if we take away one raisin, it doesn't make a difference, and I can prove it doesn't make a difference because we've done a blind taste trial. 99 raisins here, 98 raisins here. Customer couldn't tell a difference. And that's true. So you take another raisin away. And now you do it again. And now you do it again, and again, and again, and again. And each time you do it, you can prove with a proper scientific, statistical, blind taste trial that if you've got n plus 1 raisins here and n raisins here, they can't tell the difference. But you're not comparing like with like, because originally you had 100 raisins, right? It's bound to be the case that at some point in that progression, if it doesn't make a difference, 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 it actually makes a difference when you compare it to 100 raisins. 100 raisins, 42 raisins, they can tell a difference. Right? That's the compositional fallacy. It's the idea that you do one thing and it doesn't matter. That's true in the moment, okay? But if you consider that over a period of time, you compose one thing on top of another, right? Makes a massive difference. Massive change the whole thing. No one buys the damn things anymore. You go out of business, right? Yeah? That's called the compositional fallacy. Really vital. I look back on my learning and I think that was a key moment of learning, okay? Because human beings are not evolved to think like that. We haven't evolved to think what's going to happen in a year's time if someone does this all the time. We've basically, the way I figure it, we've evolved for two things. Number one is to avoid tigers, and number two is to crave sugar. That's basically my summary of evolution in a nutshell, okay? Nothing to do with the future in that long-term sense. So, in terms of software, you write a piece of code, you get a warning, it doesn't matter, it's only one warning. Well, hang on. We've been doing this for 5 years now. How many warnings have we got in total? 50,000. Right? Now you see it's a big problem, right? What's the big problem with 50,000 warnings? No one cares. I agree. That's really the biggest problem. But there's again, to use the same analogy that we've just talked about. Yeah, you don't see the one important one that scrolls by when there's 50,000 scrolling by. You never see that new one in the middle that was really important. It's just lost in the vastness of the other 50,000, right? Okay? The difference between 0 and 1, that's a really obvious visual distinction. Yeah? And you can keep that difference if you keep the number of warnings at 0, right? Yeah? This, if you think about it, gives you a very good rule of thumb for writing tests. When you write a test that it passes, should it produce output? No is the correct answer, in my opinion, okay? Why? Exactly. compositionally, right? You run them all and they all pass. You get lots of output. You run them all and some of them fail. You still get lots of output. Okay, and the failure output was way up there because we've had lots of other stuff afterwards that's obscuring that. Okay. So again, another example of composition. When you run the tests and they all pass, you want minimal output, so that you get the biggest difference between all the tests passing and something went wrong. That's the distinction you want. Okay? It doesn't matter how good it makes you feel to see all this stuff scrolling by for all the tests that pass, right? That's not really what the game's about. Okay? Okay. Oh, and the only other thing I had written down was coverage. A little bit talking about coverage. Who generates coverage stats with their tests, along with their tests? Yeah, a few hands. If you don't, you're running tests without coverage integrated into that. I strongly urge you to consider it. Okay. But to state the obvious, unless you have coverage stats with your tests, your visibility into what's actually happening is a lot worse, right? Because you could have lots and lots of tests that are running the same thing over and over and over and over again, right? And no tests for these big blobs of code. But there's no tests for those at all. There's no coverage at all for those, right? So low coverage is always a warning sign. It just always is a warning sign. Yeah. But beyond that, because that's obvious, you want to think maybe about the patterns of coverage. Yeah. If you have a code base, lots of lines of code, and if we imagine a sort of a histogram drawn sideways for the number of lines, the number of times that line of code is covered by a test, okay? Yeah. Some of them are very low and some of them are 0. Some of them are massive. Some of them are off the page even, okay? Most of them are fairly small. What do these massive ones tell you? Well, it may or may not be complex. Wherever that line of code is somewhere, it's being covered a huge number of times more than these other bits of code, these other lines of code. Exactly. It seems to me like we come back to this idea, yeah? Maybe someone's written a test for this, and a test for this, and a test for this, and a test for this. And all of the tests are actually covering ultimately the same bit of code down at the bottom of the dependency graph, right? Now, why is that potentially not a good idea? Exactly, okay? One way to think about this is to imagine deliberately changing the code. If you deliberately change that line of code, how many tests would break? A lot. Okay? That doesn't sound so good, okay? Again, we want the tests to test the thing they're testing and not to test the things they weren't designed to test. But it seems to me like accidentally we've ended up in a situation where lots of the tests are accidentally testing the same thing over and over and over again. Well, if it worked one time, why do we have to test it again with the same input, for example, right? It's just crazy. There's a lack of architecture, for want of a better word, right? Because when we talk about things like coupling, we want low coupling in our code, right? Sometimes that's a very vague thing. People don't really have a strong feeling about what that is. Well, this can give you a really strong, visual indication of what the coupling's doing. You look at the coverage stats, and there's a massive spike of coverage here. Yeah? It's telling you you've got coupling where you don't necessarily want it. You don't want that, okay? You want low coupling in the code where you want low coupling, okay? And coverage is one of the ways you can start to get a handle on what that actually means and measure it, okay? I forget the name of the gentleman who was on just before lunch in the other room over there. He was talking about XP, practices of XP, okay? He made the really excellent point that measuring, it's not about measuring something so you can manage it. It's about measuring something so you can improve it. Yeah, I would definitely echo that sentiment very strongly. The best companies I visit are the ones that have a mentality of improvement. They're always trying to improve. The manager doesn't say, you know, how are you doing? Kind of a pointless question like that. Or the worst one I see is when they come up to Artem and say, Artem, that stuff you promised Friday week, is it going to be ready Friday week? And Artem says, yes, right? You set that up, right? The manager says, that stuff that you said was going to be ready Friday week, is it going to be ready Friday week? He says, yes. Okay. So the next day I come in, I say, Artem, that stuff that's a little bit closer to Friday week now is still on track. Things have slipped a little bit, but he said he thinks he can get it back. Okay, so he says, yeah, fine for Friday week. And I keep coming in as the manager, keep saying, is it going to be ready Friday week? And eventually, of course, things have got later and later, and Martin cracks. He says, no, I'm not going to have it ready for tomorrow. Right, yeah? And the manager says, well, when is it going to be ready? And he says, maybe another 2 weeks. Imagine the poor manager, right? Yesterday, it was going to be ready tomorrow. And suddenly, in 2 days, it's got 2 weeks later. Well, no, it hasn't. There was an illusion in place the whole time, right? And it's a mistake to think that the manager is at fault there, or that Artem is at fault, because it's the system that is at fault, right? There's no visibility in the system, and that is why the manager is saying to Artem, that stuff you said was going to be ready Friday week, is it going to be ready Friday week? The problem is he doesn't know, he's having to ask, right? There's no metrics measuring the things that are important. Okay, that's something that's so important that everyone should know that without having to ask for it. It's something that's otherwise invisible, right? Otherwise you just set the whole dynamic up and it just goes wrong. Yeah, it's the system, it's not the individuals, okay? So yeah, measurement is good. I'm all for measurement and metrics. As long as it's done sensibly. And just to put a bit more meat on that, in my opinion, the best way to do measurement is to think about what you're going to do with the results of your measurement before you start to measure. Okay? In other words, you say, we're going to measure something. I'm running out of paper here. Yeah? And we're going to plot it on a graph, whatever this thing we're measuring is, okay? But the point is we thought about it beforehand, and we say, this is the green area. If it's in that band, everything's fine. If it's in this band, clacks and clacks and clacks and warning, danger, danger, bad things are going to happen, okay? And this band in the middle is the amber band. And the point is, when the metric that you're measuring goes into the amber band, you've thought about it already, and you have some strategies that you've thought about of how you can get it back into the green band. Yeah? Because otherwise, you know what's going to happen. It's going to drift down and down and down. Composition fallacy is going to kick in again. It's only a little bit below the green line. Doesn't matter. Tomorrow it's a little bit further below the green line. It doesn't matter. Another day a little bit further below the green line. It doesn't matter. Suddenly you're nearly in the red. Okay? You've made it too hard to do something because you haven't thought beforehand, what are you going to do if that value drops into the amber? Yeah? If you've thought about that beforehand, everyone's agreed. The whole team's agreed. We had a meeting about that. We said if it drops into the amber range, this is what we're going to do. That's the way to think about metrics. That's the way I'd urge you to think about it. Okay? Proactively. Okay. I don't particularly have anything more on my list of things to talk about. We've got 5 minutes left. General mucking about and questions, if you like. Okay. Right. 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 Mm-hmm. Yeah. Right. Okay, so I think I understand the question. If you have a situation where I can run this test and I pass this number in and this is the answer, or I can pass a different number in and I get the same answer, then there's some element of choice about what number I pass in. And maybe I could choose random numbers, Fibonacci, whatever, but there's some possible variation. Right? What I don't like about using random numbers is, assuming the random number isn't one, generator isn't one you've written, is you're crossing an external boundary. Okay? So, there's no right or wrong, but the few times I've had that situation in the past, and one time I remember sitting with someone at a company where they had that situation, what I recommended doing was a data-driven approach. So here's the test, and we run it with this number, and we realize that we can put a whole variety of numbers in there. It shouldn't make a difference to the answer. Okay? That's really what you're testing, isn't it? Now, you could obviously generate a random number and feed it in. Next time you run the test, generate a different random number and feed it in. Okay? Yeah, maybe. Okay. But what I don't like about that is if the test fails, it's easy to fall into the trap of not being able to reproduce that failure because you don't know what random number you sent in. Okay? So, what I would suggest instead is you run the random number generator, let's say 100 times. You gather those 100 numbers, and then you run the test in a loop 100 times, feeding in those 100 numbers. Okay? Because that way you're still getting the essence of what you wanted to get, that when you use a whole batch of random numbers with some corner cases and all that kind of stuff, right? According to our understanding, it shouldn't make a difference. This should still be the answer. Okay? But if something goes wrong, we're still getting lowering the risk where we wanted to lower the risk, but we've still got that safety net that if one of them does fail, we can actually pinpoint what the actual failure was based on the parameters that were being sent in. That's kind of the third option I would try and give you if you gave me that same two choices like for the Princess Bride. Okay? You could, and they're two different tests, you're right, okay? The test that they work with genuine random numbers versus the test that if I pass a whole battery of numbers in here, it doesn't matter, I get the same answer. Perfectly valid to see those as two separate tests. The intention is very clearly different in those two cases, I would say. Yeah. And often that's one of the difficult parts of software. It's realizing what your intention is, right? Because the name of the test should reflect your intention of what you're doing in the test. Good tests are very intentional. Yeah? Okay? So, given we've got a few minutes left, let's just revisit that idea we talked about, and I said I might come back to. Someone mentioned a unit test is a test that tests a method. So imagine we've got a class with whatever name, it's got 4 methods, A, B, C, and D. Right? Here's my unit tests for that. Doesn't matter what the unit test class is called, but it's got 4 test methods. Guess what they're called? Test A, which tests A, test B, which tests B, test C, which tests C, and test D, which tests D. And you look at the body of one of those tests, let's suppose it's called test C, and what do you find inside the body of that test? Well, what you find is a call to C, right? As you'd imagine, given the name of the test. You've got duplication, right? The name of the test isn't telling you something that you didn't already know by looking at the body of the test. And that's because that's the wrong level of abstraction, okay? You don't want to be thinking about what happens when I call that particular method with this particular argument. That's basically just testing the code does what the code does. Yeah? What you really want to test in a unit test is a scenario of these objects are in this particular state and they're connected in this particular way, and I do these 5 steps, and when I do the 6th step, this should happen. But only because I did these 5 steps first, alright? There's a very definite linear flow. It's a story. Okay? It's not that when I add an element to a collection, right? It's not that when I add an element to a collection, the collection is one bigger than it was before. That's a rubbish test, right? No. You want to think about what you value when you're using a collection, okay? If I add one element to a collection, sure, the collection is one bigger than it was before I added it, but more than that, if I try and retrieve the element I put in, it comes out, right? There's a sequence, an interaction of elements, of method calls that you do that collectively give you the overall behavior that you want, okay? These methods don't live in isolation. It's how they interact with each other, okay? I'm ignoring you, I've seen you, thank you, okay? Give you another quick example. Encrypt. Yeah? If you encrypt a method, how do you test that? I've got a string and I feed it into the encryption algorithm and it gives me this gibberish, which apparently is the encryption. How the hell do you test that? You have a decrypt, right? You feed it back into decrypt and you get the string that you first started with. Yeah? Don't think about methods individually. It's how they work in combination when you've got a linear story. That's what a unit test is. It's a linear story. Okay? We're out of time. I have to let you go. I'm here tomorrow. If you have any other questions, just grab me. Thanks a lot.